Unit 8, Lesson 5, More Estimating with Probabilities. I can explain why the results from repeating an experiment may not exactly match the expected probability for an event, and I can calculate the probability of an event even when it comes in the sample space, when the outcomes in the sample space are not likely. So I've got a typo there, but I can fix it. All right, so let's estimate. So which situation would you worry most about? That the situation is most mathematically likely. Oops, I didn't mean to do that. All right, so the weather forecast calls for a 20% chance of rain tomorrow. The probability of a tornado is 1 in 10. The probability of snow this week is 0.85. So I need to convert all of these into either percents, decimals, or fractions so I can compare them. So I'm actually going to convert them all into decimals because that's the easiest in this circumstance. So if you remember, you move the decimal 2 places to the left to change a percent to a decimal. So that's 0.2. 1/10 really means 1 divided by 10, which you can do in your calculator, or 0.1. And this one is 0.85. So which one am I most which one's most mathematically likely? Situation 3, there's an 85% chance that it's going to snow. Okay? So when they say worry about, they don't mean like worry, I'm nervous. It means like which one would I need to prepare for? All right, so you're going to spin the spinner 10 times and record your outcomes here. So there are these different spinners, and if you use the slides on Google Slides, you can actually click, and you're going to choose one of these spinners and spin it in the app. But since this is a PDF, I can't really do that, so don't worry about this slide. All right, so it says, do any of the spinners have the same sample space? If so, do the probabilities, do they have the same probabilities for each number to result? Okay, so a sample space are the possible outcomes. So for this one, for letter A, I have 1, 2, 3, 4, 5, 6, right? Those are my possible outcomes. For B, I have 1, 2, 3, 4, 5, 6. I don't have any numbers other than that. For C, I go 1 through 12. It looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then for this one, I only have 1, 2, 3, 4. So they asked, do any of the spinners have the same sample space? Yes, A and B have the same sample space. If so, do the probabilities for each number, do they have the same probability? Well, this has each number repeating 2 times. This has 6 going twice, and there's only 1 1. So A and B have the same sample space. But different probabilities. Alrighty, so for each spinner, what is the desired for each spinner, what is the probability? So that's going to be a fraction, desired outcomes divided by total outcomes, that it ends on a number 1. Well, that's 2 out of 12 possibilities. So 2 out of 12, or you could reduce it and say 1 out of 6. For this one, it would be 1 out of 12. Because there's only one number 1 out of 12 possible outcomes. For this one, it is also 1 out of 12. It's kind of funny that B and C have the same probability. For this one, half of the spinner is actually the number 1, so that would be 1 out of 2. which is kind of odd because you would think that it would be 1 out of 4 because there are 4 possible outcomes, but that's not the case here because the 1 takes up half of the total spinner. All right, so now let's look at the probability of getting a 3. So that's 2 out of 12, or you could say 1 out of 6. That's 1 out of 12. That's 1 out of 12. Now for this one, I have to consider what I think this is. So if I was gonna, oops, I didn't mean to do that. So that's 1 out of 4 if each piece is exactly the same size. Because the 3 takes up 1/4 of the total spinner. All right, what is the probability that you will spin something other than a 3? Ooh, so this would be 10 out of 12 or 5 out of 6. I'm reducing it. Other than a 3. So this would be, there's only 1 3, the rest are something else. That'd be 11 out of 12. That would also be 11 out of 12. And that would be, well, if I know 1 of the 4 parts is a 3, then that means 3 out of the 4 parts is not. So if you look at the comparison between this slide and the slide before it, you can see that when you add them, you get a total of 1. All right, when Noah spun spinner D, he put it on his closed binder. So I want you to think of a 3-ring binder. So like a big binder with 3 rings, and you've got it sitting on that binder. So it's not flat. The spinner is not flat. And he never got a 1 in all of the spins. How might you explain the problem? The binder, or the spinner, was not sitting flat. So was it a good experiment? I would argue it's not, because if the spinner doesn't have equal opportunity to make its way around, that would cause a problem. If the 1 is tilted up, the weight of the actual thing that spins is going to always go down. All right, when Hans spun spinner C, he never got any 3s, so he says the probability of getting a 3 is 0. How might you explain this problem? Well, there's an 11 out of 12 chance to get something that is not a 3. Okay, so, and how might you explain this problem? It is unlikely that he would get a 3. All right, next one. So I understand how to determine the probability of a spinner. So if you were doing this in Pear Deck, you would drag that dot somewhere in here. All right, for some situations where things are not so evenly divided, some experimenting may be needed to determine the outcomes that actually follow our probability expectations. So when you have spinners that either the numbers aren't equally visible there, or the size of the sections are not the same, you might actually need to do some experiments, or you might need to redivide your spinner like I did with my drawing tool to really look and see, okay, what is the probability that's going to happen? So Andre picks a block out of a bag 60 times, and he notes that 43 of them are green. What should Andre estimate for the probability of picking out a green block from the bag? Well, 43 out of 60. That's his probability. That's what he knows is going to happen, because he doesn't have the contents of the bag spilled out in front of him. He has no real idea of what is going on because he can't see all of the possible outcomes. So he has to assume that it's 43 out of 60. So then it says that Mai looks in the bag and she sees, okay, so she looks in the bag and she sees that there's 6 blocks in the bag. Should Andre change his estimate based on that information? Well, so really there weren't 60 blocks in there. There were only 6. So, but he got 43 out of 60, right? So should he change his estimate? Yeah. He should change it to there are 6 blocks, right? And he knows that 43 times out of 60, he got a green block. So that means it's about 4 out of 6 times are going to be a green block. So what should the new estimate be? 4/6. So why should he change it? There were only 6 blocks in the bag. All right, so a chance experiment is done a few times, and the fraction of outcomes in a certain event is used as an estimate for the probability of a future event. Okay, so when a chance experiment is done a few times, then you can use that as a determining factor. Okay, if you can't see what's happening, you can't see all the possible outcomes, you can use that experimental probability. The more trials you do, and that's the important thing, the more trials, the closer it's going to be to the computed or the mathematical probability. Okay, so the more times you do a chance experiment, the closer you're going to be to that probability. So a chance experiment is repeated many times, but the fraction of outcomes for which a certain event occurs does not match the actual probability. What are some reasons this might happen? So a chance experiment is repeated many times, but the fraction of outcomes for a certain event occurs does not match. So it just doesn't match the actual probability. What are some reasons? Well, the experiment could be flawed, like, for example, the binder. So the experiment could have a flaw. What's another reason? You didn't do it enough times. Okay, so those are 2 reasons. If you're in Pear Deck, you're probably giving me other answers. So what are some reasons that things might happen? Those are some of the reasons. It could be that it is very unlikely that outcome would occur. Like, for example, 1 out of 12. Well, it's more likely that all the other outcomes are going to occur. You're going to have to do it a lot of times to get that probability to match up. So now you're going to do your cool down. A person suspects a standard number cube is not so standard, meaning that it's rigged or it's incorrectly made. He rolls it 100 times and it lands on 6 40 times. Another person rolls the cube and 100 times and it lands on 6 42 times. A third person rolls the cube and it lands on 6 33 times. Based on the results, is there evidence to prove that the number cube is not a standard number cube? Explain your reasoning. So I want you to think about your possible outcomes and your desired outcome. So your desired outcome is the number 6. What are all the possible outcomes on a fair die or for a fair option when you're rolling this dice. How many possible outcomes are in that sample space? So what should be, how often should that 6 occur? Okay? So I need you to make sure that you submit your assignment, and I hope you have a great rest of your day.